Hi, this is a supplemental lecture for week 6. It's on DOE optimizing designs. This should be fairly short. We are not going to try and get to the bottom of all of the ways that you can optimize. However, there can be some times when you might want to find what's called a response surface and find a maximum or minimum of a function. And DOE, of a response, really, of like, how do we maximize the right party connect, or how do we minimize the cycle time of doing something? And there may be one or two factors that we can tweak a little bit to find that sweet spot. So that's what we're going to cover right now. We're going to cover something called response surface methods. And we're going to cover one in particular, and then I'm going to show you at the very end, a really simple way to do it, which is not quite necessarily the absolute best statistically, but I think you'll get it and understand it. So response surface methods, and there's a couple of them. One is called Box-Benken, and there are many others, but and another popular one is called central composite. We're not going to cover Box-Benken. We are going to do central composite. Okay, so let's get to it. We'll do it in Minitab, and I'll show you how it all works. There will be a cool little plot that we'll cover. All right, so here's the example that we're going to do. We're looking at a call center, and this is the one that is in your week 6 book, slides 95 through about 102. And this is the call center one, and let's suppose that we're trying to maximize the right party connect. And we have put together a design experiment where we had 7 factors, and these were the factors. So the number of products that were in the mailing, the experience of the CSR, the pre-experience of the CSR, that is, if they came into the call center with already call center experience, the previous average handle time that they've had, whether they received coaching or what level it was, 2 hours or 1 hour, the phone offer of deal A, let's say it was a package bundle of products type A, and there's a phone package offer of deal B, and those would be either no, they got the offer, or yes. Okay? And coded, they become all -1s and +1s. And I want to point you to 2 things. One is that some of these are numerical variables, and some of them are not. Whoops, what's that? Get rid of that. And some of them are not. So, for example, these are cats, right? Yes or no's. So when we talk about a response surface, we can't go in between yes or no. Maybe, maybe that would do it. But we can't have like a 0 level in there. But, like see on number of products, we could go halfway in between. Like instead of 5 or 20, we could offer, say, 12 or 13. So we could, in theory, get a 0 point in there. Same with, well, the way we set it up in experience of CSR hasn't been a good one, or it hasn't been one that would make itself that. We've defined it as a cat. And we've defined this as a cat. This is kind of a cat here. But this, A and E, are both nums. Okay? And so when you have num variables, you can go in between and run what are called center points. You can run also something called a star point or axial point. So we will do that. Now, just to remind ourselves, there's a happy coincidence here, and that is that when we ran it before, we found that the A and the E and the AE interaction were all significant. Now, before we also go on, and I'll do this in Minitab just to remind you of what we did before, I want you to note that we probably coded this in a way that I would not normally want to do it, but this is to emphasize that it really is arbitrary what you call a -1 and a +1. Here, if we were going to redo this, I would probably want to switch around the 1 and the 2 hours to put the 2 hours at the high and the 1 hour at the low. But since we've got it in here this way, I'm not going to switch it. But it does work either way because it's just arbitrary. if you call it down, up, or up, down, basically. Okay, so not to be too confusing on that, let's go ahead and take a look at at what we had before. So this was our data that we had before. I'm going to copy that and put it into Minitab, and we will analyze that just to remind ourselves of what was significant. Okay, let's put this in, and what I'm going to do is I'm going to let's let's analyze this factorial design. Let's run them all. Oops, got to specify the lows and the highs. And here's my response. I'm going to graph it. I'll use the Pareto. There we go. And this is just to remind ourselves that we did find the A and the E and the AE interaction to be significant. So I know I'm cutting this short, but we normally, well, let me just do it normally. We're going to keep all of the main effects, and we're going to keep the AE interaction. And there we go. Those are the only three that turn out to be significant, so let's now get rid of all the others. Let's get rid of them all. AE and the AE interaction. Click okie dokie, and there we go. All right, so there's our model. And we'll note that our model, by looking in here, is whoops, there's our model right there. And we'll note that we get a minus coefficients, and so forth. So if we're trying to maximize things, we're going to want to, we have a, let's just kind of talk it through, and I'll show you why it's a little bit difficult. So we've got y is equal to some constant, 62. I'm going to truncate. I guess that would be 63. It would be closer. I'm going to round it a little bit. Minus 5.9 times A minus 12.5 times E minus 6.7 times AE. Now here's an interesting thing. If we wanted to maximize this response, we put A at a minus, which would make this positive, right? Positive 5.9. We'd put E at a minus, which would make this positive 12.5. But now check this out. If A is minus and E is minus, well, then AE is positive, and this is a negative. So there's this trade-off between, geez, where do we set it? All right. So we're going to note that both A, which is the number of products that we offer, and E, which is the training that we give the CSR, are both adjustable by us. So we might want to go in between those different points, right? So we found that, for example, if we plugged in all of the +1 and -1s, if this is, let me actually plot the interaction plot so you'll see what that looks like. So if we plot in the factorial plot the interaction plot, I'll set it up. Here's AE. Whoops, I don't want AF. Oh, let's leave it in there just to show how much bigger the effect is of AE. I got to select a response. There we go. And you'll see that, for example, the maximum response is somewhere, at least from this prediction, whoops, of AE. You see that this has a very big interaction, very big difference between having it at this level and this level. If we have it at the 1, there's a big deal, between a big difference. If we have E set at 1, there's a big difference with what A we use. So anyway, so we've got something that looks like this, and it looks like we're going to maximize it at -1, -1, and that's at least with the interaction in there. But let's take a look at what that whole surface is, and for that, we have a cool plot here, and I'm going to show it to you. It's called the contour plot. Actually, before we get to that, let me show you in the slides. We go back just a little bit. Here we go. Yeah, so we're starting at 95, and let me show you what we had right here. So if we looked at the main effects plot, we might think, oh yeah, well if we can maximize it at E equals 1, and at E equals -1 and A equals -1, that's great. But what if there's a curvy surface in between there? You know, what if it's somewhere in between that it's maximized? Because we've got this interaction, which is kind of maybe screwing things up. So what we're going to do is we're going to do a different plot that's going to help us see that. And it is called a contour plot. So if we go to Stat, DOE, Factorial, Contour Surface Plots, and I'm going to make a contour plot and set it up. I'm going to make A and E. And actually, I want to make sure that I get the same as I have on here. If I get different, we'll just switch them around. Whoop, I did. So if you do AE, you get this right there. So I'm going to redo it so that I get the A on the side and the E on the bottom, which is just selecting E and then A. Okay, ready? Here we go. So this will be what we had in the book, or something very, very similar. And you'll note that it colors these different things. The light color is the smallest, and the dark color is the maximum. You have to look at every one of these plots to make sure. And the way to read this plot is to think of it this way. As you're going toward any of these lines, you see how there's these different isoclines or whatever, these different color bands. As you go, you want to go perpendicularly to that to maximize. So for example, if I were here, I would want to walk in this direction to kind of go in the steepest way up that hill. So we're going up a hill when we go there. And we can see in the darkest region right over here is the maximum region. So yes, it's maximized over here, but it's also kind of maximized over here. So wouldn't it be nice right now, all we've really run are these points right here that I'm going to highlight in just a moment. I'm going to erase all of this. I'll put this back in. But all we've really run are these points. So what we'll want to do is we'll want to run some other points to see which direction the maximum is. So in a central composite, what you do is you run a bunch of center points, a few center points, and then you run some star points. So you're going to run a point over here, you're going to run a point over here, you're going to run a point over here, and you're going to run a point over here. And now if we find that, for example, this is even greater than this, it might mean that the curvature is in this direction. If we turn out that this is even greater than this, we might even go in this direction. But and anyway, that's kind of how the central composite works. So let me just do one of those in Minitab, and then we'll show you how it worked analyzing the data, or what it is. So so to create a central composite, you go to DOE, Factorial, oops, not Factorial, Response Surface, sorry about that, Create Response Surface Design, and we're going to have two factors. By the way, you usually want to keep it to two factors when you're doing this, especially when you're starting to do optimal designs, or optimizing designs, I should say, not optimal designs, it's something different. You want to keep it to two factors because then you can really kind of explore that curvature. So really pick the big ones. In this case, we only had two big ones, which is good. So we're going to pick the 13. And, you know, just for fun, I'm not going to randomize it. There's a reason. That's just so it can be easier to read. And here's what Minitab did for us. It created a number of different runs. Let me make it bigger so we can see it. A number of different runs with A and B. And it created a bunch of new points. So let me show you. There's a few points that we've already run. we've already run the points that I'm going to mark here with the marker. We've already run this point. This is one edge of the cube. We've already run this point. We've already run this point. We've already run. These are just the four edges of that square. But here are some new points. You'll see here's a star point. This is a point in the center, but on the side of A, in the center of now it's calling it B. It's really E from before. Here's a new point. Here's a new point. And here are the points in the center. So it runs 1, 2, 3, 4, 5 points in the center, and 1, 2, 3, 4, what are called axial or star points. And if we go back to our previous drawing, see if I can find the, do the contour plot again, just to make sure that it gets right on that right thing. Oh, I can't do it anymore. That's right. All right. When we ran this, what we're doing is we're running these axial or star points. I'll just point out right here. We already ran these, and now we're running 5 center points. Whoa, hello. 5 center points, and then these 4 axial points. That's what's going on, and we're going to determine which direction should we go to maximize this design. Okay, so here is the design. That's exactly the one, but it's no longer in standard order. I've just taken it in a different order. And we'll note that some of these points have already run. You don't have to run them again. And so let's go ahead and run this for the data that are in the file. Okay, so here are the data that are in the file. And we can imagine that Minitab created this, and we ran those extra points, and we got these responses. So let's go ahead and analyze that in Minitab. Okay. Here's what we had. Let's go ahead and analyze this in Minitab. We're going to analyze the response surface. We've got A and E. There's our low and high. Now notice it's different. You see that? There's our lows and our highs in our response. And let's go ahead and check it out and see what we got. So again, we can look at all these different p-values, but I think the key thing to look at is really the contour plot. So let's go ahead and do that. Okay, so we've got our central composite in here, and let's just go ahead and run the analysis of the response surface. And I've got in here, here's my response, and I'm going to include all the terms that I can. And let's just take a look at what that gives me. Notice that it doesn't give me this a squared, this quadratic term in A to be significant, nor does it give me this quadratic term in E to be significant. Those are insignificant. That's no big deal. But it does try and find something on this curve of the AE and AE interaction. And so let's see where, according to this particular model, where we're going to maximize. So let's make a contour plot. And if we go here, let's take a look at our contour plot. I've already got it set up. And there we have it. And it looks like, again, from our model here, that we are going to, now it, for some reason, it does 2 colors, blue and green. Like I said, it does, multiple things. So it looks like if we were trying to minimize, we would again be there. And to maximize, the interesting thing is we're there. We're at A equals 1, or A is continuing to be, on the positive side. And we're moving in that direction rather than in this direction as we originally thought. And that's because that interaction term is just very, very strong. So anyway, so that's what's going on. And let's take a look at it from a fairly high level to see what really happened here. Now, I should let you know that the response surface here is what you get if you just run the contour plot without any DOE, which is fine too. It's totally fine, and this is going to give you a slightly different answer. It's just in the way that it calculates things, where it's maximizing things around, A equals 0 and going in that direction. So anyway, so that's what gives. Now, let's see. So what we've done now is, I guess the point is that what we've done is we've run this and we found that the maximum is in this direction right here. If now I put this into coaching hours and number of products, actually not just into -1s and +1s, but here's coaching hours and here's the number of products. So we're maximizing it with more coaching hours and with a sweet spot of around 10 products or something like that. And what we might do is we might want to run another follow-up experiment there. Now, what I want to do is I want to show you the sort of the simpler way of approaching this, and I think you may find it helpful. So let's see if I can go back to. For some reason I'm not able to do that. PowerPoint and my presenter just don't always mix right. Okay, so let's take it a different way. Suppose that we had run our points like this already, and here was, let's say this is A, so this is +1, and this is -1, and here's E, and this is +1, and this, whoops, I'm sorry, this is -1, and this is +1, right? So here's our scale. And let's suppose, for example, just for giggles, that we found the following. We found that this gave us a 43. I'm just making these numbers up for the moment. This gave us a 56. This gave us a 63. And this gave us a 71. What you might want to try and do is try and go in essentially, think about it, because these are much greater than this, you might want to go, but there's also sort of a preferred direction like this, you might want to just try and move a little bit in this direction. So your next experiment, thanks, I wrote over the whole thing. Oops, now I really wrote over the whole thing. There we go. I think this was 71. All right. So what we might want to do is just kind of move in this general direction right here. So one way of doing that would be to run a new set of points, and I'll do that by a new color here. Let's use green. I might want to run this experiment, right, to see if, for example, I'm going to maximize, if I still keep increasing in this direction. And if I do, then maybe I'll even get a stopping point if I run a center point right there, which I could do. Maybe I'll even get a stopping point. But essentially, running at these different intervals. So let me now put it sort of in the real world, not the real world, but to use this example, A was at the -1 level was 5 products, and this was 20. So what we might want to run is A equals 10 and 10, and maybe this is two products, right? So A is equal to maybe 2 here, and 2, and E was what was it? 1 hour coaching, 1 hour per week, and that was -1, and +1 was 2 hours per week. So we might want to run this at 10, 2 hours per week, and 2, 2 hours per week, and this one might be 2, instead of 2, maybe we want it at 3 hours per week. Okay, so then this would really give us an idea. This is not the most efficient way of doing it statistically, but you can see that what you're essentially doing is you're essentially trying to move in a direction that's maximum. So the process would be to look at that 4 square, see what the direction is that you're trying to move that makes sense, by looking at the contour plot of that, and then going ahead and doing the next 4 points and looking to see at the contour of that. For example, if it's going this way now, that means that you've more or less reached the maximum right over here. On the other hand, if it continues to go in this direction, or if it maybe levels off this way, that would help you understand what the next experiment would be, or maybe you're done. Okay? So anyway, hopefully that gives you an idea of where you'd want to go with optimizing design. We covered the central composite. You can see it is a little bit tricky, but hopefully I gave you an alternative that you can use that isn't that tricky, and just sort of envisions, if you have 2 significant factors, look at that contour plot and in Minitab and see if you can go in the direction that makes sense any further. I should say, if you want to just do the contour plot directly without having to go into into DOE Analyzer, it will produce a slightly different contour plot, but it's in graph contour plot, and you just have to put in the response and the Y and the X. And there's a few other things that are in here, levels and all that kind of stuff, if you really want to know. But I would just use the default, and that's where the picture in the book comes from. And you can see that you're getting these pools of maxima, which are kind of coming up around here. Whoops, hello. Which are kind of coming up around here and around here. So going in that direction makes sense, or settling around there makes sense to maximize. Okay, hopefully you found this reasonably okay, and that you'd be willing to try at least the square, or to call for help if you need to optimize a surface. Now you know it's there, you can do it.